In this video, we're going to continue our discussion on exponential functions. And right now in red, I have graphed the exact same function that we saw in our video from yesterday. And there are a few things we can pick out about this. For instance, I have 2 here multiplied by the 3x. So that means that my y-intercept right there, where we cross the y-axis, must be at 0, 2. Because an input of 0 for x, 3 to the 0 is 1, 1 times 2 is 2, and that's where we get that output. Now, I'm going to convert this to a table, and it lets me take a look at 5 ordered pairs that it's put in there for us. For instance, if we put 2 in for x, we would do 3 squared first for 9 times the 2 to make 18. If I put in -2, 3 to the -2 is 1 over 9, and then we take that times 2 for 2/9, and this value right here is the same as 2/9. Now, some other things I want to show you here as I put in other numbers. If I put in like -3, -4, -5, -6, -7, our numbers continue to get smaller and smaller and smaller. Maybe this one doesn't look like it, but this number here is 0.0009. So it has an extra 0 here before we get to the number, but after the decimal place. And so as we get more and more negative, what we have on our, we never actually get to 0, but we do come very, very close. And let me come over here and zoom in. Let's look at this. So if I zoom in, we're not touching the axis, even though it sort of looks like we are. I can do that, and actually we're just slightly above here as we go over. So we continue over. Let me change this so we're looking from -10 to -9.5. Okay, again, it sort of looks like we're touching, but if I zoom in, we're just above. And so nowhere on this will we ever actually touch 0. Let me go back to a normal screen here. I'll make my y-axis go from -7 to 7. There we are. So we never actually touch the x-axis, so that means we have something called an asymptote. And I'm going to add in what that asymptote is, and it's the equation y equals 0. I just draw that straight across here, and so the word here, I'm going to add in the word for our notes. This is called an asymptote, which is a line that an equation approaches but never touches. So we would never touch the x-axis, we would never touch y equals 0, but we're getting closer and closer and closer to it as we go out to the left of this graph. Okay, so that's something about yesterday's here. Let me hide this and this here as well, and let me open up this one. This is 5 times 1/2 to the x, and this one looks a little bit different. Right? As we go off to the right, we have our asymptote. So I can click this back on and notice here that we're approaching the x-axis as we go to the right. And that's because as we get bigger numbers, like say if we pick 4, 1/2 to the 4th is 1/16. And so we're taking 5 and we've divided by 2 4 times. We would have 5/16. At 8, 2 to the 8th, that's going to be 128. That's not right, 256, something like that, and then we take 1 divided by that very large number. And so we have 5 even divided by that as well when we multiply the 5 in. So my denominator gets huge, but my numerator stays 5. So once again, we can never actually touch 0. This one ends up going a different way though, because this one is showing what we call decay. And let me get a note thing out here instead. This is showing decay as it decreases from left to right, where the other one showed growth. As we went left to right, we grew, we got bigger. Decay, we go down. Once again, my 5 out front here would indicate my y-intercept, and then we don't touch the axis, the x-axis, anywhere else. All right, just to make a point here, if I threw like a -4 down, all of a sudden that's not our asymptote anymore. Now our asymptote is y equals -4. So we would get very close to -4 for my y's, but we would never actually ever get there. Okay, so that is our information for today on exponential functions. For now, we are done.